So whether we use inductive coupling and magnetic resonance for short distances, or the wireless power transfer through electromagnetic fields, it depends on the required level of power, but the range of application is very wide. Okay, so remember I said I emphasized the radio frequency to direct current conversion and the frequency which was used earlier for the wireless power transfer. It's all about efficiency, in the sense that if we compare the inductive coupling, the short range, this is short, and the electromagnetic radiation, we can see here that as the distance is closer, the efficiency of the transfer from the transmitter to the receiver gets higher and gets much lower as we move away from the transmitter. Mainly, I'm not going to go into the details, but just to say, because the received power, this is the received power, and this is the transmit power, depends on the antennas, depends on the distance, depends on the wavelength, which is a function of the frequency. This is the reason why Tesla used 150, it was too low to be successful. Brown used the gigahertz much higher, and that's why he succeeded. And probably if we implement millimeter wave much higher, we will have more chances to be able to collect energy wirelessly. So, as we go higher in the frequencies, for instance, for a millimeter wave, it is not only beneficial and attractive for data transfer, but also for power transfer. Now, in the next two parts, I will talk a little bit on how one of our results on how to improve the efficiency for far field, wireless power transfer, and how we can gain in terms of harvesting energy from RF signals. First, RF wireless power. So remember we said we have a power beacon that is sending power to, this is the user terminal, okay? No need to look into the details. So this, imagine it's like your phone, which is receiving data from the base station, but the addition part is that you have this power, it is wirelessly fed. The efficiency, again, these are not complicated. I'm just would like you to see that this is the power source. It goes like for the power to be received here at the battery, it goes through this process that is DC to RF conversion. Then the efficiency of the beamforming of the power travels in free space. At the receiver, you have the receive antenna efficiency, the rectifier, which converts the RF to DC, for storing in the rechargeable battery. So mainly the efficiency is a product of three terms: the transmit efficiency, the receive efficiency, and the efficiency of transmission over space. Here, the state of the art, we can achieve up to 80% at the receive antenna as well. But the problem is with the transmission over space.